Hello everyone, my name is Alexander Zelenin.
Hello, my name is Alex Haletsky.
Today we will solve medium problem third one from dictionaries and hash maps. It's called Sherlock and Anagrams. Let's go and take a look at this one. I had take a look right before the stream and it not looks as easiest one. It looks like harder than previous ones. Let me try to explain what we have here. So we got some string, for example, mom. There is 3 letters. We need to find count of substrings that make an anagrams. For example, in this string mom we have a substring like m and m, the first example. That is exactly the same letters, but they are in the different positions. And we have mo and om, which like represent the same count of letters. So in both of them we have one o and one m, one o and one m. So in this case we define that this is similar anagrams. This is a bit unclear, so we will go through a few more samples and we'll take a look what we have here. So as an input we got a string, just a string, that's all. And in the task itself we just receive a couple of strings, maximum up to 10 strings. And each string is from 2 to 100 symbols. Each symbol is Latin letter from A to Z. And we will need to return number of anagrammatic pairs for each string. So here is next example. We have a string ABBA. For this string we will have 4 pairs. First pair will be AA, so the first letter and the last letter. Then we have pair AB, BA. So since AB have one A and one B, and BA also have one A and one B, we have pair B and B. And at the end we have pair ABB, BBA. Okay. So, and the next string ABCD. All these letters, all the letters is different, so we have like 0 pairs here. We have also another example. I fail LUHKQQ, which have 3 pairs. The first pair is letters II. Second pair is AFA and FAI. So they have the same amount of same letters. And the last example here, and also QQ. And the last example here is KKKK, which have 10 of such anagrams. For just 2 letters K and K, we have 6 anagrams, like first K, second one, first and third one, first and fourth one. Then we have then we have second and third one, second and fourth one, and third and fourth one. Then we have combination of 2 letters like KK. We have KK and KK starting from the second one, first one and last one, and also like middle one and last one. Okay, so three total of them, and the last one will be like by length of three symbols. So like KKK from the first symbol and KKK from the second symbol. Okay, maybe it looks complicated because it is.
It's complicated. I really don't understand what to do.
Okay, I will try to explain a few approaches. Right now, I just feel that approaches in my head are non-optimal, but anyway, better to solve task even in an optimal way than not to solve it at all. Okay, Alexei, go somewhere. I will continue to explain what I want to do here. We will create all possible substrings.
Sorry,
Yeah,
I'm
we'll
back.
great. We will create all possible substrings from the initial one. Then we will compare them with each other and find is it anagram or not. Um, to do this, we will make some cycle that will change the length and change all possible substrings. So, like we will create a substrings of one symbol, like one, 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 and so on. But maybe we don't need to create with one. I think there are possible optimization when we can start with two symbols. So we will create a string like if, fa, ai, il, lu, and so on. So there will be a lot of strings. It will consume, like memory consumption will be really high in this case. But right now I doesn't have other ideas. One of my ideas is to use a dictionary and put indexes of the same letters, for example, I and I, and then start with like with the coordinates of these letters and go back and forth to find some combination around them. But I just doesn't feel that we will able to code this in time and it's possible to have a lot of bugs. So we will start today with a simple approach and maybe tomorrow we will optimize it for better one. So first of all, we need to create our dictionary that will have all possible substrings. So as a key for this, I will use length of the substring since or maybe it can be an array then. If we will start with one, yeah, let's start with array. It will be array of arrays. But originally the topic is dictionaries and hash maps, so I already feel that it's not an optimal one. But again, doesn't matter for now. So we have our string s. We will go through our string and increase length starting with let me think. So at the start we want to have strings by the length of 1, and we want at the end have length of string up to as length minus 1. So like this one. So let's do like this exactly. So from 1 to s length minus 1. Okay. And right now, but since we're going through the indexes, we need to go from... No, okay, this is length. This is length. So then we have like this range of string lengths from 1 to maximum the length of 1. So like from 1 to 3 in this example, and from 1 to this length. I don't want to count the letters. And inside of this, we will go from the position of 0 to position of s length. Let's rename, instead of I, let's name it max length. So we'll have a better name, and it will be more readable. So inside we will go from the first symbol of a string to the maximum last starting symbol. So for example, if we have max length of 1, we will go to the last symbol and everything is fine. If max length is 2, the last starting point of a string of 2 symbols will be the symbol right before the last one. So it will be like this. So we will add our substrings to substrings. So max length, we will create an array here. So it will be a new array if it's required. And we will push new substring to this array. So we add a new substring, which will be as slice, and we want to get from the k number to k plus max length. Sorry, let me rename it from max length to just string length, because it's not the max length. It doesn't matter anything. So at this point we got all combination of our substrings. Let's take a look what we have in our array, just for like better understanding what is here. So we have arrays for input like a, b, b, a. In our array we have a, b, b, a, b, and b, b. So it looks like we miss the last one. That means that I forgot about something by some reason. I mean, we need to have like 3 letters also here. So length must be of 3 letters. So let's maybe do like this. Yes, but also it's a bit strange since maybe let's start with 0. I just need to check the simple things. Why it's not processing. So it still doesn't work by some reason. Maybe less than equal. Yep, less than equal, sorry. So now everything looks fine. So we still need go from the 1 that we don't need to have anything like this. So we have every letter alone, then we have all combination of 2 letters, AB, BB, and BA, and all combination of 3 letters. Now we will check all of them against each other. So like we will check AB with BB, which return false, and we will test AB with BA, which should return true. So let's create our test function. Test anagram. I hope I write it. Anagram. Which will take string 1 and string 2. The purpose of this function is to count amount of letters and compare that they are the same. So we will go, we create the letters dictionary. Which will store something like A5 and so on, so count of symbols. Then we will go through S1. And we'll increase count of letters for every of this letter. So letters I should be equal itself or 0 plus 1. So like this. And for string 2, we will do barely the same operation, but instead of adding letter, we will S1. There should be S1. No, sorry. Instead of I should use a letter itself, like this, Okay, and here we will have S2, second one. But instead of adding, we will removing. And now we will go through our object and see that all of the keys is, all of values here is 0. Because if some of them is not 0, but like -1 or 1 or some higher value, that means that this is not pair at all. Or we can just do it here. Yes, instead of making additional cycle, let's go here. So if this is now we will anyway need to go through 1 second. If we will have some letters that are in the first one but not in the second one, that will means that there will be some another letters. So we can compare that this is less than 0 and return false. But if everything is fine, we can return true here. So we will go through all our substrings with same length, and we will count of all anagrams that we have here. So let's create counter of 0, return it. And now we need to fill all numbers here. So we will go through our substrings. And here we will have string length as a key, and no, sorry, strength length. It will be the second argument. First argument will be an strings itself. So strings. So we will need to compare each string with another one. I'm not sure, maybe we don't need the string length here, but okay, it doesn't matter. So strings is array like this one, and we will go like to compare the first one with second one, first one with the third one, then we go for the second one, and so on. So let's create another cycle here. Or we can make it just for each here. Okay, strings for each. We will go through every string, and for every, no, better I will go, sorry, with just a cycle. It will be a bit easier, while I is less than strings length. We'll go to the next string. So, and for let's create it like this. First string equal strings I, and inside of this we will have another cycle. So from the I plus
more cycles for the gods of cycles.
Yes, there is a lot of cycles. As I told, this is not optimal solution at all, but at least it should work.
I think the time capacity for this solution will be huge.
Will be very huge. We will calculate it later on.
See, I understand. What does it mean, time capacity?
Nice. So, and now we'll have a second string. And right now we will able to test them with our function. So if they are the same, first string, second string, then we will increase our counter by 1. Yay, something like this. I hope so. Let's see.
Let's see.
Looks like our output is wrong one. I just not sure why it's so, but let's see what was considered as pairs. So let's start with adding console log here and take a look what strings was considered as the same ones. So we have a lot of empty strings by some reason. Maybe the problem with that I starting to use an array and we have the first one is the first empty one, but I think it should be like this. Let me check one more time. Yes, but still by some reason we miss a lot of values. So in this time we have output only for BB, but we miss substrings like AA and so on. Let's add here also some console log and take a look what we are comparing with each other. So we have first string equal to second string, and we will see what comparison we have here. So we start with comparing B and B, which is fine, then B and A, again B and A, but why we skip the first letter? Let's take a look what we have in substrings at all. I just feel that something is wrong inside of substrings. Maybe I still miss something. So by some reason we miss the first letter now. The first letter. Why we start from 1 here? My god. This doesn't allow. Yep. So by some reason I put 1 here instead of here, and this was an error. So looks like our test cases works. Let's try to submit. Maybe it will not work for all the cases. I presume it will not work for all the cases since we have a very huge complexity, and it might work slow and might fail for some of them. But maybe let's just hope it will not fail for. Oh, it still fails for one of the cases. For the third one. But we still got some amount of points, so the task is solved, but in non-optimal way. So by this reason, one of the tasks was not able to complete it in time. So we will optimize this algorithm tomorrow. But for today, let's calculate what we got here in meaning of space and time complexity. Okay. So for the space complexity, we have only this array of arrays. So it will be like two-dimensional arrays. in this array we will have first of all we will have s amounts of subarrays, and each subarray will be maximum length of s again, so it will be like s square if I write. So we have two cycles. First, so we will have inside of this something like we have test information here before, so you already see what is inside. So for I think it will be a square, right? Yes, it will be s square. So for each string we'll have another string and so on. For every another letter will consume a lot of additional memory. Okay, let's go for the time complexity. Since we doesn't store anything else here, we doesn't have anything that contribute to space complexity also. For time complexity, first of all, we have S for this cycle, then we have S for this cycle, and inside of this we make a slice and push, but creating an array of maximum of S elements, maybe it's another S. In the worst case, it will consume, like if it will be big string from the start to end, it will be again S. So at least for this one, we already have S cube complexity. Later on, we go through our substrings. So we have S here. But this will be just as length, and in previous one it was also as length. So what are you talking about? For each, so it will be again S cube. S cube. If we don't talk about this part, and for test anagram, we will also have two strings. For the first string, we go through the complexity of test anagram is not so huge. It will be for this one just S1, and for this part it will be S2. So total complexity of test anagram will be S1 plus S2. And for memory consumption, also for memory consumption we have an object here, object letters, which will store some amount of letters, but since we have just 26 of them, it will be 01. So like it will not increase above the sum limit, so it doesn't matter. So we have here complexity, like depending on the on both of the string, and both of the strings is also maximum length is like string, so it will be like S plus S, so it will be 2S inside of this. So at the end it looks like it will be like complexity string in power of fourth. So if we have a string of 100 elements, it will be like we'll need to. So sorry, is it right?
Yes, it's right.
Yes. So for
100 million.
operations for just a string with 100 of symbols. So
I think that's why we failed test number 3. Just
yep,
timeout.
yep. So uh, I hope we will find out better algorithm tomorrow, and we will optimize our code to pass all the tests without the problems. Thank you for watching. Have a
I
nice
hope
day.
to. Thank you. Thank you, Alexander. Bye.